Okay, so we resume our lecture with the discussion about the memory that um, an object occupies. So we discuss the classes, objects, and memory next. In the previous discussion so far, we have seen that don't confuse yourself when we are actually discussing this topic. This is just for understanding if you need to know how much memory is occupied by a program. So in that case, you need to know how objects occupy space. Otherwise, you can just continue with the way we discussed so far. So in reality, actually, when we declare an object, so far we have said that object is based on the template of the class. For example, if we say there are a few data items, so they would be created in the memory, and then we have member functions of for example, there are a few member functions. So far we have said that this object would be based on the template. If we make another object, so again we would have the data item of the new object, and we would have member functions generated for the uh, second object. In reality, this is not the case. Only the data items would be given space in the memory, and the member function would be declared only once. It would not be generated every time. So each of the objects, they would make use of the member function generated once, because the same member function are generated again and again and again, so it's just a waste of memory. Um, so the conceptually it would look like something like this. When we make three objects, so each of the three objects, this member function would belong to this one, this member function would also belong to this one, it would also be used by this one. So the three data items, the three objects, the data items, they would occupy some space in the memory, they would be given some space, but the member functions not like f1 f2 f1 f2 f1 f2, so they would be just replications. So rather than making them three times, they would be just given space once. Say if you want to say call this as the member function of say object1 dot function1, so it would serve as a member function of this object. You say object2 dot function1, so it would then be used as the member function of this object, and so on. So um, this is about the memory and the how actually space is provided to these functions, to these objects. But if you want to continue as we discussed, you can, it is simpler to visualize each object as containing both its own data and its own member function. So you can just visualize the same as we have discussed so far. So it has some data items, and then we have member functions. You can just continue in this way. But as I said, that if you want to estimate the size of executing program, then it's useful. You need to know that the member functions are only declared once in the memory. They are actually assigned the space in memory only once. Next we have the static class data. So there are a few things that you can declare static. You can declare the data item as static. You can declare the member function as static. So how would it work? So let's see. If we declare a data item to be static, for example, if we say this is a class with the name FOO, and it has got one data item which is static. So you should know the difference between static and automatic variable from your previous course. So if we say the object and it has data item with the of integer type, and it is static data type, and these are the member functions of this class definition, then please note that this, if you make any number of objects, object 1 2 3, they won't have the integer count as a new variable. They all would refer to one static. For them this would act like a global variable. So object 1, object 2 and object 3. If we say object 1 dot count, so it would actually refer to this variable. Object 2 dot count, so it would refer to this variable. Object 3 dot count, so it would refer to this variable. So if we declare it as a static variable, so it would be given one space in the memory, and for all the objects this would simply be this variable which would be declared only once. So if we make a data item as static, then this would be one variable for all the objects of that type, of that class. So for example, if we say as in this example, we have made this count as a static variable, and we have a constructor over here that and the body of the constructor increments the variable by 1, and outside the definition of count we have initialized this to 0. It is important that the declaration is over here, but initialization is done outside the class definition just to make things consistent, because in the previous version we said that class is only a blueprint. So this is only a blueprint, you can see from here, and this is assign some space outside the definition of the class. We say this will belong to the FOO, and it is initialized to 0, so to make things consistent. And once we make this blueprint, this count variable is static, so this is declared over here. Now whenever we make an object, so this would be based on this blueprint, and we can see from it is a constructor that would increment the count by 1. So if we say f1 object of type FOO, so an f1 object would be created, and as soon as this is created, what will happen, this constructor would execute, because this is a member function of this blueprint. So f1 would be of type this one, and this constructor would initialize the data items of f1. Since we have got what, integer count, but this count is a static variable, so this would be over here. Since this was equal to 0, when we make object, this constructor is incrementing this by 1, so count would become equal to 1. When we say f2 object, so another f2 object would be created, and you can see from here this would be based on the blueprint of the class FOO. Since you can see from here it has got one data item, but since this is static, so this would be simply referring to this data item. Once this object is created, so the constructor would be executed by default. And what is this constructor doing? This is incrementing the count by 1, so this count would become equal to 2 if this is executed. And then another object f3 is made, and once f3 is made, so the data item count would simply mean this data item, and the constructor, if increments it, so it would become equal to 3. So by the end of the third object creation, the count would be equal to 3. So when you say when you next say show me the value of the f1 dot get count, so when you execute f1 dot get count, so when you execute the get count in the f1, so what is inside the get count? It actually returns the value of the count. So the count would actually be this global variable, kind of global variable. So when it returns the value over here, it would be equal to what? The value of this variable. So it would show us 3 over here. You say f2 dot get count, so the member function of this f2 object get count would be executed. And what is this one doing? This is returning the value of the count, but count actually refers to this variable, so this would return us the value of this function, which is 3 over here and 3 over here. So all the 3 times it would print the value 333. If there were no static term over here, then there would be a count variable over here, a count variable over here, and count variable over here. When they are initialized, so the value would be equal to 0 0 0. If f1 executes, so this count would be incremented by 1. F2 executes, so the count variable of this object would be incremented by 1, and this would be 1. So if you say get print, so then this would be printed, and then the result would be 1 1 1. So in case of the automatic data item, it should be 1 1 1, but since this is declared as static, so there is only one variable made, and all the three objects, they increment them by 1 1 1 respectively, and then the count should be equal to 3. So if you make a data item static, so it would be accessible by all the objects, and it would be declared only once. That's the summary. So you can see from here automatic data item. So for each object there would be new data items created for each object if the variable is an automatic variable, and if the data item is static, so they would be declared only once. So this would belong to this object, this would also belong to this object, and also belong to this object. So if you say object2 dot data3, so it would refer to this variable. If you say object1 dot data3, so it would again refer to this variable. So for all the objects, they would see these variable as belonging to that object, but it's actually declared only once. And if it is an automatic variable, so it would only belong to this object. So object1 dot data1 would mean this one and not this one. If you say object2 dot data1, so it would mean this one and not this one and not this one. So that's the difference between static and automatic. And why is it important? So it's shown over here that at times we might, for example, say there is a road racing game. So you have the different objects are the cars. So then each car must know that how many of the other cars are in the race. So then all the objects should have access to one common variable, which would be the number of cars which are still currently in the race. So in that case we would make the count equal to static variable. So for each of them it would be one variable. Okay. Now next we have constant member functions. So if we make a member function as constant, for example, if we say if we make this class definition, the name of the class is a class, and this is the data item. If we make this member function just like as we have made thus far, if we make another member function and say make this as constant, so if a member function can be declared constant this way, and a constant member function means that it cannot change the data item of this class. So if you want to declare a member function and define the member function in such a way that you just don't want this member function to change the data item of this object. Okay, so if you want to make an object, it has certain data, and then you want to make a member function, you just want this to show you the data item, but you just don't want it to change the data item, so you just make it a constant. So by making it constant, it won't be able to change the data items of this object. It would just show you what's the value of the data item, but it would not change if it is made constant. As you can see from here, this member function is made constant. So then alpha equals to 99, this would give you an error. So it would not be able to change, it would just be able to show you the value. This is how you can make a member function constant. You have to write the keyword right after the definition of the right after writing the name, but before the body of the function. You just write const, and this would make it a constant. So as an example, we have the same distance class as we have mentioned this a few times. This example is as two data items. This is the first constructor, no argument, second constructor with two arguments. Then we have this get distance member function, show distance member function, and then we have got what add distance member function, but we have declared here equals to what constant. So this member function, whenever you call this member function, this would not be able to change the value of the feet and distance. So for example, you say distance d1, then you call d1 dot add distance. So if you call this d1 dot add distance, this would not be able to change the feet and inches of the object d1. Okay, so if you have d1 object, these are the different member functions. This member function, this member function, these are the constructors. So if you call this one, this would change the value of the feet and distance inches. If you call this one, this can show you the value of the feet. If you call this one, then this member function inside, if there is something, say for example feet equals to something, if you write this thing, it won't be able to change. So because you have made this equal to constant, so this member function would not be able to change data items of the object because this is constant. You can also see that there is an object passed by reference. So you also, if you don't want to change the object, you just pass it as a constant, then you would this function would also not be able to change the object that is passed by reference. So it won't be able to change this object, it won't be able to change any data item of this object. So this would just perform some addition, give you result, that's it. It won't be able to change the any of the item, the argument that is passed by reference, because if you don't want to change, just declare here a constant. If you don't want to change the data items of this object, write here a keyword constant, and then it would be made constant. So you can see from here the definition of this, the body of this add distance function. You can see there is a temporary object created, and then what is being done over here, that the temporary object, the inches and the feet of the temporary object, that would get the value of the inches of the object that is passed, and the since this is whatever function calls in whichever object, if you call this one, so inches would mean that item of that object, and this is what the argument passed. So add these two, it would be saved in the temporary. Similarly, see if you say d1 dot add distance, so then the feet would refer to the d1 objects data item, and since d2 is passed by reference, so d2 dot feet would mean the feet of the data item of the object d2. Add these two, save this in the feet, and then return. But you can see from it, if you write here feet equals to 0, if you want to change, say d1, if you have made an object d1, and if you call the member function d1 dot add distance, you change feet, this feet actually refers to data item of d1. If you want to change it over here, it would give you an error. If you want to change d2 dot field, since you have made this constant, so you cannot change this argument even if this is passed by reference, so you cannot change this thing, so because it is made constant. So these two things would give you error because of the keywords constant over here and constant over here. You can just use this the way we just have discussed this earlier, but in this example we have added the keyword constant, which would disable this feature in this function. The rest of this example is the same as discussed earlier. The next thing is the constant objects. So if you make an object as a constant, for example in the same example distance class, which has this blueprint, if you make an object of this class, so football for example, if you make an object of class distance, but if you declare it to be a constant, So then once declared, you can't change the value of the data items of this object. So this object would have feet and inches, whatever the value it gets, then it won't be able, you won't be able to change it. So if you say football, since this is an object of class distance, it has member function get distance. If you say football dot get distance, you can see from here the user would provide some input, and that would change the value of the football object data items. But since you have declared it constant, so if this would give you error. You can only, once you have declared it, it's a constant, then you can just only access the data item, then you can show it. So you can execute this second member function, but you cannot execute the first member function. This would give you error. And why this would give you error? Because you have made this object as a constant object. So with the constant objects, the constant member functions, they should, like that, they match with each other. If you make an object constant, since a constant member function cannot change the interest, and you already have made it constant, the object constant, so the items would stay constant, and this member function would be best match for the constant objects. So that's all about objects and classes in this chapter. Let me quickly discuss all the things in Urdu that we have discussed so far, and if you have understood till this point in English, you can leave. I'm going to review the things in Urdu quickly for the guys who haven't understood. अच्छा जी, सो इसमें अभी अब तक हमने कहा कि जी अगर हमारे पास क्या है, एक तो हमने मेमोरी के बारे में कुछ डिस्कस किया कि जो ऑब्जेक्ट है से हमने एक ब्लूप्रिंट बनाया क्लास का, जिसमें हमारे पास क्या है, हम कहते हैं कि उसमें हमारे पास एक ऑब्जेक्ट में कुछ डेटा आइटम्स होंगे और उसके कुछ मेंबर फंक्शंस होंगे. सो फर्स्ट हमने यहाँ पे कहा कि जी ऑब्जेक्ट्स जो है अगर हम बनाते हैं इस ब्लूप्रिंट के हिसाब से, सो डेटा आइटम जो है इस ऑब्जेक्ट का, जब कहते हैं कि जी हमने ऑब्जेक्ट बनाया, सो चूँकि इस ब्लूप्रिंट के हिसाब से होगा, इट वुड हैव 2 डेटा आइटम्स. सो ये जो डेटा आइटम्स होंगे ये मेमोरी में इसके लिए कुछ जगह दी जाएगी, बड़े जो मेंबर फंक्शन है ये सिर्फ एक दफ़ा डिक्लेयर कर लिए जाएंगे. पर जितने भी आप ऑब्जेक्ट्स बनाएंगे, आपने एक ऑब्जेक्ट बनाया, दूसरा ऑब्जेक्ट बनाया, सो उसके डेटा आइटम्स भी उसी तरह से होंगे जो कि ब्लूप्रिंट में हमने कहा है. लेकिन जो मेंबर फंक्शन है ये एक ही दफ़ा जो बन चुका होगा, सो रेपिटेशन हमारे पास नहीं होगी. सो मेमोरी में हमारे पास मेंबर फंक्शंस एक ही जगह पड़े होंगे. अगर इस तरह आप समझ सकते हैं ठीक है, अदरवाइज यू डोंट नीड टू विजुलाइज दिस वे. आप विजुलाइज करें कि जी इसके साथ भी बना, इसके साथ भी बना, तो हमारे पास क्या होगा, इसको समझने में आसानी होगी. अगर मेमोरी वाइज आप देखें कि कितनी जगह इसने कॉपी की है, देन उसी केस में हमारे पास सिर्फ आप उसको इस तरह से आप देख सकते हैं इसको. फिर हमने कहा कि जी स्टैटिक क्लास डेटा. सो कुछ चीज़ें हमारे पास क्या है, इसको हम स्टैटिक रख सकते हैं. स्टैटिक नंबर 1 हमारे पास क्या है, अगर हमने एक डेटा आइटम को हमने स्टैटिक डिक्लेयर कर लिया क्लास के डेफिनेशन के दौरान, सो क्लास एक ब्लूप्रिंट हम डिक्लेयर कर रहे हैं और हमने कहा कि जी एक फिला वेरिएबल डेटा आइटम जो है स्टैटिक. सो स्टैटिक वुड मीन वर्ड, मेमोरी में इसको एक दफ़ा बना लिया जाएगा. अगर आप एक ऑब्जेक्ट इस ब्लूप्रिंट के हिसाब से बनाते हैं, ठीक है, सो उस ऑब्जेक्ट में चूंकि हम तो इस ब्लूप्रिंट के हिसाब से बना रहे हैं, सो उसमें ये वेरिएबल होगा, बट दिस वेरिएबल वोंट बी अ न्यू वेरिएबल. दिस वुड मीन, इसका मतलब क्या होगा कि ये वही वेरिएबल है जो एक दफ़ा बन चुका होगा. अगर हम एक दूसरा ऑब्जेक्ट इसी ब्लूप्रिंट के हिसाब से बनाते हैं, तो उसमें भी जो ये वेरिएबल है, तो ये क्या होगा, दिस वुड एक्चुअली रेफर टू दिस वेरिएबल जो कि स्टैटिक बन चुका होगा. ठीक है, तो जितने भी आप डेटा आइटम बनाएंगे सब में अकाउंट वेरिएबल होगा, जिसको आपने स्टैटिक, अगर स्टैटिक बनाया हुआ है तो वो नया वेरिएबल नहीं होगा, वो हमारे पास एक ही वेरिएबल को सब रेफर कर रहे होंगे. सो इससे क्या होगा, सब ऑब्जेक्ट में ये एक ही वेरिएबल है, कोई हर एक के लिए नया नहीं बनाए, हर एक में ये एक वेरिएबल जो है वो इसी वेरिएबल को रेफर कर रहा होगा. सो ये हर एक का हिस्सा है, बट हर एक में अलग अलग से नहीं बना, हर एक में सिर्फ एक ही दफ़ा बन चुका और हर एक में उसको हम एक्सेस कर सकते हैं. सो ये एग्जांपल जो है इसमें काउंट को स्टैटिक बनाया गया है। सो एक ब्लूप्रिंट हमने बनाया, हमने कहा कि जी इसमें हमारे पास एक काउंट वेरिएबल है, जो ही हमने उसको कहा स्टैटिक, सो बस एक दफ़ा बन जाएगा। फिर अगर हम एक ऑब्जेक्ट बनाएंगे f1, सो उसमें काउंट जो है वो एक्चुअली इसी वेरिएबल को हम कह रहे हैं। अगर हम यहाँ पे दूसरा वेरिएबल दूसरा ऑब्जेक्ट f2 बना रहे हैं, सो f2 बन जाएगा, बट इसका जो काउंट वेरिएबल है, सो काउंट एक्चुअली इसी वेरिएबल का नाम है। ठीक है, वो कोई मतलब मेमोरी में अलग से जगह नहीं होगी उसके लिए। हम f3 कहते हैं, सो f3 में भी जो हमारे पास ये काउंट होगा वो इसी वेरिएबल को कहा जाएगा। चूंकि हर दफ़ा जब ये ऑब्जेक्ट बन रहा है तो वो क्या कर रहे हैं, उस वेरिएबल को इंक्रीमेंट कर रहे हैं बाय 1। सो जब ये फर्स्ट टाइम हम बनाएंगे तो ये काउंट 1 होगा, फिर सेकंड जब ऑब्जेक्ट बनेगा तो काउंट 2 हो जाएगा, फिर ये काउंट 3 हो जाएगा। सो ये सिर्फ शो करने के लिए कि जी ये जो काउंट है ये तीनों का हिस्सा है, ये अलग मतलब तीनों के लिए एक ही वेरिएबल है, अगर आपने इसको स्टैटिक डिक्लेयर कर लिया। नेक्स्ट क्या है हमारे पास, ये हमारे पास यहाँ से कंसेप्चुअली हम देख सकते हैं कि जी अगर एक ऑब्जेक्ट जो है उसका डेटा आइटम ऑटोमेटिक वेरिएबल, मतलब आपने स्टैटिक डिक्लेयर नहीं किया, सो ये डेटा आइटम जो है डेटा 1 इसके लिए अलग से बनाया जाएगा। हम दूसरा ऑब्जेक्ट बनाएंगे, सो उसके डेटा आइटम्स जो होंगे वो अलग से मेमोरी में जगह लेंगे। सो उसी नाम से ऑब्जेक्ट 2 डॉट डेटा 1, ऑब्जेक्ट 2 डॉट डेटा 2। अगर हम एक थर्ड ऑब्जेक्ट बनाएंगे, सो वो भी हमारे पास क्या होगा, उसमें डेटा आइटम्स जो होंगे, डेटा 1 एक आइटम होगा, डेटा 2 आइटम होगा। सो यू से ऑब्जेक्ट 3 डॉट डेटा 1, ऑब्जेक्ट 3 डॉट डेटा 2। लेकिन अगर हम इसी वेरिएबल को से d3 हम वेरिएबल को हम स्टैटिक डिक्लेयर करते हैं और क्लास के डेफिनेशन में, सो फिर क्या होगा, एक ही दफ़ा ये होगा। ठीक है, यू कैन से ऑब्जेक्ट 1 डॉट डेटा 3, सो वो क्या होगा, इसी वेरिएबल को आप रेफर कर रहे होंगे। अगर आप कहते हैं ऑब्जेक्ट 2 डॉट डेटा 3, सो वो क्या होगा, यही वेरिएबल होगा। अगर आप ऑब्जेक्ट 1 डॉट डेटा 3 आप उसके चेंज करते हैं, सो आप इसी में आप चेंजेस कर रहे होंगे। अगर आप कहते हैं ऑब्जेक्ट 2 डॉट डेटा 3, तो वो भी आप इसी में चेंज कर रहे होंगे। अगर आप कहते हैं ऑब्जेक्ट 1 डॉट डेटा 1, सो वो आप इसको रेफर कर रहे हैं एंड नॉट दीज अदर टू। अगर आप कहते हैं ऑब्जेक्ट 2 डॉट डेटा 1, सो आप इसको रेफर कर रहे हैं, बिकॉज अगर आपने इसको ऑटोमेटिक डिक्लेयर किया हुआ है, सो वो ये वेरिएबल होगा और नॉट दिस वन और दिस वन। लेकिन अगर वो स्टैटिक है, सो सब में हमारे पास क्या होगा, ऑब्जेक्ट 1 डॉट डेटा 3, सो इट वुड बी दिस वन, object 2 dot data 3, so it would be this one, object 3 dot data 3, so it would be this one. So अगर आपने एक वेरिएबल को स्टैटिक कर लिया डिक्लेयर, so it would be declared only once. फिर मेंबर फंक्शन की बात आती है कि मेंबर फंक्शन को अगर आपने कांस्टेंट इसको बना लिया, किस तरह बनाएंगे, अब उसके नाम के बाद क्या कर ले, एक कांस्टेंट कीवर्ड लिख ले। अगर आपने इसको कांस्टेंट डिक्लेयर कर लिया, सो ये जो मेंबर फंक्शन होगा, अगर आप ऑब्जेक्ट बनाएंगे तो उसमें मेंबर फंक्शन होगा। ये मेंबर फंक्शन जो है इसके थ्रू आप इस ऑब्जेक्ट के डेटा आइटम्स को आप चेंज नहीं कर सकते अगर आपने इसको कांस्टेंट बनाया हुआ है। ठीक है, अगर हम कहते हैं कांस्टेंट दिस फंक्शन, सो इसमें आप क्या कर सकते हैं, इस वेरिएबल को फिर आप चेंज नहीं कर सकते। और यहाँ पे अल्फा इक्वल्स टू 99 लिखा है, तो दिस वुड गिव यू एरर। ठीक है, सो मेंबर फंक्शन को कांस्टेंट क्यों बनाते हैं, बिकॉज आप चाहते हैं कि कुछ फंक्शन ऐसे हो जो कि हमें जस्ट डेटा प्रोवाइड करे लेकिन उसको चेंज ना करें। तो उस केस में अगर आप एक्सीडेंटली इस मेंबर फंक्शन के थ्रू आप उसको चेंज कर रहे हैं, सो इसको चाहिए कि आपको ये यहाँ पे आपको एक एरर मैसेज आए कि जी ये मेंबर फंक्शन एक्सीडेंटली डेटा आइटम्स को चेंज कर रहे हैं। सो उस केस में आप क्या करें, इसको आप कांस्टेंट बनाएं, तो फिर आपके पास इस गलती का इसकी कोई गुंजाइश नहीं होगी। फिर नेक्स्ट जो है हमारे पास एग्जांपल हमने डिटेल में डिस्कस कर लिया। नेक्स्ट हम क्या कर सकते हैं, हम ऑब्जेक्ट्स को भी कांस्टेंट बना सकते हैं। किस तरह से, अगर हमने एक ऑब्जेक्ट बना लिया, ठीक है, से हम कहते हैं ये हमारे पास ब्लूप्रिंट है इस क्लास का, और इसके हम क्या करना चाहते हैं, हम एक ऑब्जेक्ट मेन फंक्शन में इसी ब्लूप्रिंट के हिसाब से इसी क्लास का एक ऑब्जेक्ट बनाना चाहते हैं। जस्ट लाइक हम कहते हैं कि जी कांस्टेंट इंटीजर, सो ये कांस्टेंट इंटीजर a, सो एंड इंटीजर a इक्वल्स टू 10। सो फिर हमारे पास क्या होगा, पूरे प्रोग्राम में हमारे पास जो है a की वैल्यू हमारे पास 10 रहेगी, बिकॉज दिस इज डिक्लेयर्ड एज अ कांस्टेंट। ठीक है जी, बिल्कुल इसी तरह से हमने क्या किया, हमने यहाँ पे एक ऑब्जेक्ट बना लिया और उसको हमने कांस्टेंट डिक्लेयर कर लिया। सो पूरे प्रोग्राम में इसके जो डेटा आइटम्स होंगे वो हमारे पास कांस्टेंट होंगे। उसको फिर आप चेंज नहीं कर सकते। अगर आप इससे इस मेंबर फंक्शन के थ्रू आप चेंज करना चाहते हैं तो ये आपको एरर देगा, बिकॉज आपने इसको कांस्टेंट डिक्लेयर किया हुआ है। अगर आप यहाँ पे कांस्टेंट ना डालते फिर आप क्या कहते हैं फुटबॉल डॉट गेट डिस्टेंस, तो फिर आप ये फंक्शन कॉल कर सकते थे मेंबर फंक्शन। लेकिन अगर आपने ऑब्जेक्ट बना लिया उसको आपने कांस्टेंट डिक्लेयर कर लिया तो फिर हमारे पास क्या होगा, उसके डेटा आइटम्स आप उस फंक्शन में फिर आप उसको चेंज नहीं कर सकते। सो यू कैन आप जो ऑब्जेक्ट्स है उसको आप एज कांस्टेंट बना सकते हैं। So that's all about this lecture. If you have any question, you can talk to me during the interactive session. Thank you very much.